All right, in your textbooks, page 254, let's have your homework out, unit numbers 1 through 19. Yeah, some of us are forgetting some things from the past, so we will have good review as we go over the homework here. Yes. All right, let's take a look at the homework together here. And yesterday we began talking about finding the total number of possibilities that exist in some situation. And we said that every individual possibility is referred to as a blank, or as in blank. What do we call a possibility in an uncertain situation? No. Outcome. And then each decision or each group of outcomes is referred to as an event. There we go. So in Kara's case, as we look at number 1, we're trying to find all the possible outcomes. Kara, it says, has 3 different skirts, 3 different shirts, and 2 different pairs of shoes to put together outfits for school or whatever, I guess. Well, this choice of skirt is an event with 3 outcomes. The choice of shirt is an event with 3 outcomes. The choice of shoes is an event with 2 outcomes. But the total number of outcomes in the entire situation, we would find, it says, by making an exhaustive list. And we said, no, we are too lazy. So instead of doing that, we use something called the fundamental counting principle, which is a fancy way of saying, class, we multiply. And what do we get, Luciana, for the total number of outcomes, the total number of outfits Kara could put together based on those 3 events? 18. How many had 18 different possible outfits she could put together? How about number 2? Breakfast menu offers pancakes, French toast, or waffles with a choice of maple syrup or strawberry topping. How many different menus are available? Jalen, as you put the water bottle on the floor, your answer is? 6. Because you have the event of what bready breakfast thing are you going to have, and then you also have the event of what topping goes on it. Number 3, each gift bag includes a bouncy ball sticker and cookie. Okay. There are red, and I was like, is that or? No, that's and. Okay. There are red, yellow, or green bouncy balls. We're not sure what color you're going to wind up with. You could either get an iris sticker, a lily sticker, or a daisy sticker, so it's a flower sticker. And you're either going to get a chocolate chip cookie or an oatmeal cookie. And the boys are like, can I trade my sticker for a cookie? Anyway, how many different gift bags could be made? Kirsten? 18. 3, 3, and 2. Number 4, lunch combo includes a sandwich. That's either a cheeseburger, a chicken sandwich, or a fish sandwich. How many like fish sandwich? And we're like, no, not so much on the fish. Yeah, not the most popular menu item out there. You get a side, French fries, onion rings, or coleslaw. How many like coleslaw? I've never learned to like coleslaw either. And a drink, soda, water, or juice. How many different lunch combos are available? Ben?
27.
27. How many had 27 lunch combos? And again, we didn't do this with exhaustive lists because we're too lazy. We use the fundamental counting principle for those. How many got 4 for 4 on the opening set? All right, questions on those? Any questions? How did you get that number? Any questions? All right, let's take a look at some review here. Numbers 5 through 8, it's been a little while. It says express each fraction as a decimal. Round to the nearest thousandth if necessary. Well, some fractions to decimals we have memorized. Most of these aren't. But number 5, we didn't memorize 3/30ths. But what can I do with 3/30ths to make it a little easier to work with, Bryson? Reduce it down to get? 1/10. Class, the tenths place is that first decimal, right? So it's 1/10, I just write 0.1. That's in the tenths place. The next one was not so easy, 2/7. Well, I didn't memorize that. I memorized 2/9, 0.2 repeating, right? But 2/7 I never memorized. And it doesn't really become tenths, hundredths, or thousandths or anything. So to make this a decimal class, I'm going to have to divide. We haven't done this in a while, have we? But we have to remember which one goes inside the house, class. The top. In this case, the 2. And of course, outside the house is the 7. And we're going to put some zeros here. Now, it said round to the nearest 1,000. How many decimal places is thousands, class?
Two.
3. Tenths, hundredths, thousandths. But class, if I'm going to round to the thousandths, that means I need to know the next digit because the 4th digit tells me how to round. So I'm going to need to put 4 zeros. And then it's a matter of saying how many times does 7, class, go into 20. And how many times? 2. Almost 3, but not quite, right? 2 times 7 is 14. Then we subtract to get 6 and bring down another 0. 7 goes into 60. 8 times, that's 56. Leaves us with 4 left over. We'll bring down another 0. 7 goes into 40. 5 times, because that's 35. That leaves us with 5 left over. We bring down the final 0. 7 goes into 50. 7 times. Now it's going to keep going, right? But I don't care. I'm cutting it off right here. What does the 7 tell me to do, Joel?
It tells you to round up.
To get?
0.286.
Good. So we'll say their answer is approximately 0.286. How many had 0.286 as your answer? How many like, yeah, I kind of forgot about that. It's been a long time. Yeah, okay, do you remember it now? Remember it now, coming back to you. Look at the next one. 7/15. Well, that's about a half, right? 7.5 is half of 15. That's almost a half, but it ain't exactly. So I got to do what, class? Divide. In the house, we put what here, Corey?
7.
The 7. And outside the house, we put
15.
15. And 15 is one of those awful numbers to try to divide by. We're going to put our 4 zeros here. How many times do you think 15 goes into 70? Make a nice guess. 5. All right. 5 times 5.
25.
And carry the 2. 5 times 1 plus 2.
75.
Oh, it just missed. That's okay. Because now I know it ain't 5, it's 4. So you make an educated guess if you're not quite sure, and you roll with it. If it doesn't work, that's okay. Don't sweat it. You know what to do next time. Now, 4 times 5, we know is going to work here, Corey. 20. Carry the 2, we get 60. We subtract to get 10, and then we bring down a 0. Corey, how many times do you think 15 would go into 100?
6.
Let's try 6. 6 times 5.
30.
Carry the 3. 6 times 1 plus 3.
90.
9. We subtract, we get
10.
10. We bring down a 0. Wait, 100. I just saw this, didn't I? What's it going to be?
6.
And then another,
6.
and another,
6.
and another. This is going to keep going. But we're rounding, class, to what value? The thousandths place. So we're going to cut it off here anyway, Corey. We're going to say their answer is approximately what?
0.467.
0.467. How many had 0.467 as your answer? Did anyone have 0.46 repeating? Because you're like, well, it said round if necessary, and I don't think it's necessary. I'd rather just do this. I have no problem with that answer either. All right, questions? In that case, by the way, you would say equals 0.46 repeating. It's approximately 0.467. So you could even use the equal sign if you did the repeating thing. Questions on 7? Well, let's go to number 8. Now, there is a shortcut here. We don't necessarily have to use it. Griffin, what do we want to do on number 8?
I did 11, putting it inside and putting the 25 outside.
Good. And so we put some zeros here. And let's see, 25, we can think money, right? Quarters. How many quarters in $1.10?
4.
4. Not evenly, of course, but there's 4 of them because 4 times 25 is
100.
100. And so if we subtract, we get
10.
10. We bring down a 0, we get
100.
And how many times 25 go into 100?
4 times.
Evenly, right? There's not going to be anything left. Boom. There's my answer, and we're done. There's another way we could have done it. Jalen?
You multiply the top and bottom by 4.
If you multiply top and bottom by 4, it gives you 44 hundredths. Class, how many digits is the hundredths place? 2. And you just put the 2 4s in the 2 spots. And you could have done it that way also. Either way works. How many had 0.44 regardless of the way you found it? All right, did much better there on number 8. Questions on that? All right, let's go back to some fundamental counting principle then. Number 9, read that for us if you would. Kirsten.
A 3-digit phone extension can use any digit from 0 to 9.
All right, so how many of you are familiar with what an extension is? Like you dial the full phone number and then like the little voice on the other end says, please dial the extension of the party you wish to reach now. Okay, so there's that little extension. Well, this particular company has a 3-digit extension. We're dealing with the car insurance company from a car accident right after we get done teaching it to you guys. And so the person at the nationwide office has a 5-digit extension. This person has a 3-digit extension. Well, each digit is its own event, right? Because the first digit could be anything, 0 to 9. How many different numbers could that first digit be, Kirsten?
10.
10 different numbers. What about the next digit?
10.
10 different numbers. What about the next digit?
10.
And what do I have to do with these possibilities?
Multiply.
To get how many total extensions?
1,000.
1,000 different extensions. So this particular system can handle up to 1,000 employees. How many had 1,000 different 3-digit extensions? Questions on number 9. Let's take a look at number 10. Street vendor sells 8 different colored helium balloons, 4 different colored ribbons, and 6 different colored weights as they sell balloons to people. How many different ways could a little kid buy a balloon? Bryson?
192.
192. How many had 192 different ways you could buy a balloon from this guy? All right, number 11. A 4-digit pin on a keypad includes digits from 1 to 9. So 0 is not an eligible digit for this pin. How many different pin codes could be used? Joel?
6,560.
1. 6,561 is correct. Did you happen to have the 1 or something go astray? Yeah, I think you multiplied 9999, right, 4 times. It's just lost the 1 there. How many had 6,561 different pins? Right, 9 digits, 4 different times. So not 9 times 4, but 9 times 9 times 9 times 9. Number 12, a coin is flipped 8 different times. Elaine?
8 outcomes.
No, there's way more than 8 different outcomes. If a coin is flipped 8 times.
64.
No.
256.
256. Think about this, Elaine. You flip a coin, it's either going to be,
Heads or tails.
unless it's really muddy and it lands on the edge, right? But normally it's going to be heads or tails, right? That's what we're assuming. So there's 2 outcomes. Then you flip it again. Well, there's another heads or tails. Then you flip it again, and again, and again, and again. And 1, 2, 3, 4, 5, 6, 7. And again. And so that's how we get the 256. Does that make sense?
Yeah.
All right. Anyone go 4 for 4? These ones were a little bit harder. Anyone go 4 for 4 on 9 through 12? Anyone go 3 out of 4? You just missed one of them. All right, questions on the 9 through 12? Any questions on the 9 through 12? All right, let's take a look at the 13 to 18. It says, write each decimal as a percent. Well, class, it's really easy to make a decimal a percent. You just go,
Point,
boink, boink. And when you go boink, boink twice, what do we get for number 13, Corey?
33%.
33%. How about number 14, Luciana?
146.
146%. Number 15, Bryson.
70%.
70%. Good. Number 16, Griffin.
57.2%.
57.2%. Number 17, Ben.
1%.
1%. And number 18, Kirsten.
1,230%.
I think you mean 4,230%? Yes, that is correct. 4,230%. And number 19, a photography studio offers portraits in sizes of wallet, 4x6, and portrait. The background can be nature, solid color, or sky. Photos can be digitally printed, or both. How many different ways can you purchase a particular photograph from this studio? And let's see, you just tell me. Let's go to Jalen.
27.
27 different ways. How many had 27 for number 19? Any questions on the 16 through 19? Any questions on 16 through 19? All right. Any questions at all on the homework? Anyone perfect on the homework? A few of you. Wow, awesome. Anyone just missed one on the homework? Still really good. All right. Flip back, if you would, to page 253. Page 253. And I got some candy for the first person done with that review section, 15 to 28. So be working page 253, 15 to 28 there in the review section. When you finish, pencil down and stand next to your desk. When you finish, pencil down and stand next to your desk. You've got some memorized things there on the first section that you can use. They didn't give you that opportunity in the homework. We've got it here. Some of them you're still going to have to divide out. I will say you might want to do the top section last. So knock out the word problems, then go up to the middle section and save that top section for last. Because for most of you, that's going to be your slow section. Always do the slow thing last. That applies to speed drills, tests, everything in life. Do the slow thing last. Get everything else done first. posture there, Ben. There we go. Basically just head off hand. There we go. When the head is not supported by the hand, the brain functions better.
Okay.
Jalen's finished. And Corey's finished. Never mind, Corey's finished first. She just realized she missed one. See if you can be second. Keep yourself in the running. Score. Luciana's finished. Now Jalen's finished. Don't hurt yourself. Elaine is finished. It's evidenced by the loud crash. Joel's finished. Don't strangle me. All right, grab a seat and let's take a look at these answers. We're going to start from the bottom up, which is the way I wanted you to work them anyway. So let's start with the bottom section, and Corey gets first crack at this. Corey, a journalist is writing an article about an author of a book, article, or blog. The overall topic can be either politics, science, history, or education. How many different outcomes are there? 12 different outcomes. Excellent. Three different types of publications the author could have, and then 4 different topics. Number 28, school concerts separated into portions. The first portion is going to include a brass solo, duet, or ensemble. Second one's going to be either a violin solo. There's going to be a violin solo accompanied either by a piano, flute, or another violin. And the third section is going to be a full choral piece or a full orchestral piece. How many different outcomes? 18. How many got both 27 and 28 correct, just as did Corey? All right, let's take a look at the decimals to percents. These shouldn't have been too bad. Corey, 21.
42.7%.
42.7%, number 22.
130%.
130%, number 23.
0.81%.
Good, 0.81%, excellent. Number 24.
6.2%.
6.2% is correct. Number 25.
0.03%.
Excellent, 0.03%, and then number 26.
59%.
59%. All right, now we come to the hard part. How do we do on our division? Number 15 should be memorized as we change the fractions to decimals and then on to percents. What did you get for 15?
0.375.
Okay, you got the first step. It actually wanted them all the way to percents. How many out of habit went just to decimals? Because that's what we done on the homework. Okay, several of you. How many went all the way to percents? Tell you what, if you got all the decimals right, I'm still going to give it to you because I'm going to have you finish it out. So you're right about the 0.375. Now make it a percent.
37.5%.
37.5%. I really should have pointed out in the directions. Don't forget we're going all the way to percents, and I failed to do so. So 37.5% is correct. All right, what was your decimal for 16?
0.4.
Just 0.4?
0.42.
0.42, okay. 0.42, so what's your percent?
42%.
42%. And that one's not one we memorized, but how many realize if you just multiply top and bottom by 2, you would get 42 hundredths, which is 42%, or 0.42 as the decimal. 2/9 is something we did memorize, Corey. 0.2 repeating, but if you make it a decimal or a percent, you make it
2.2%. 2.2 repeat.
Luciana, what do you have on number 7? Well, you did decimals also, didn't you? So you had the 0.2 repeating for 17.
I had, yeah,
What would that be as a percent?
22.2%.
22, the first 2 points, so 22.2 repeating percent. Are you perfect so far on everything else? You are not anyway. Jalen, are you perfect so far? You're perfect. Okay, so let's go to number 18. By the way, I would not treat 18 as 60, 70s. I treat it as 6 7s, get the decimal, make it a percent. You said you also just went to decimals. What was your decimal?
Approximately 0.9.
Oh, because you rounded to the nearest tenth.
Yeah.
Thinking decimal. Oh, that's true. That's going to be really hard to come back and adjust to.
It'd be like 85%.
It'd be 85.7%, 0.857, so 85.7%. Number 19, we should have memorized.
25%.
25%, 0.25, 25%. And then, let's see, number 20, you would have rounded to 0.1, wouldn't you?
I rounded to 0.5 repeat. No, what?
You're not too far off, 0.05 repeating, which becomes what as a percent?
55.5 repeat.
Well, it's 0.05 repeating, 0.0555. Do the double boink, kind of like with Corey's, the 2 boinks. So 5.5 repeating. Percent should have been our answer there. Let's see, Elaine, you had percents.
Yes.
Were they all correct?
I had for 20, I had 0.06. Is that right?
Well, 0.06 as a decimal would round to 6%, and one of the nearest tenth of 8%.
Right.
I don't know. I should have made the instructions a little clearer on that. Were you perfect on everything else?
Yes.
And you were perfect on everything else? And was it just number 17, like you had the 0.2 repeating? Did you get the other decimals right?
Mm-hmm.
I'll give all 3 of you candy.
Yeah. Candy.
Everybody gets red today.
Ooh. I love red.
Nice.
Joel, were you perfect by any chance? You were not. Okay, I was just curious because you were right there in the fast finishers group as well. All right, questions. You can eat them now. Questions on these. All right, note to self. Make better directions. Make sure I point out directions a little better. Turn the page. And let's talk about probability. I referenced this yesterday. The idea of probability simply is how likely is it something takes place. If you'll note the definition of probability there on the top of, it's actually on the top of page 254. It's an event occurring, well, let's write it at the top of the page. The probability is the likelihood of an event occurring. They don't quite put it in those words. The likelihood of an event occurring. Put that at the top of page 255 or bottom of 254. The likelihood of an event occurring. For instance, you know, guys, as you get a little bit older and you're like, that girl's really pretty. Do you like me? Check yes, no, or maybe. And so anyway, and so you're like, I got a 1 in 3 chance. No, you got a 0% chance, but you can still give the note. Anyway, the problem, or maybe as a Colts fan, what's the probability that the Colts get a playmaker in the draft this year?
Zero.
Zero, because Chris Ballard's going to trade back. Or maybe, as a Pacers fan, what's the probability we go on a run in the playoffs and win it all?
Zero.
All right. That's subjective. Strictly speaking, if 20 teams make the playoff now, which is stupid in the NBA with that 9th and 10th seed playing the 7th and 8th and all that nonsense, like, just take the top 8, come on, people. But anyway, strictly speaking, the odds of winning it, if we just look at the numbers, would be, well, if we make the playoffs, we're 1 out of 20 teams that make it. One of the 20 teams has to win it, right? Why not the Pacers?
Zero.
Zero. Anyway, but that's all probabilities. How likely is it that something takes place? And so the way we find probability is, you see it here, probability of an event occurring is the number of desired outcomes over the number of possible outcomes. The number of desired outcomes over the number of possible outcomes. That's what it says in that little yellow shaded box. I just like this as a little bit of an abbreviated form of it. It's a little easier to say. Now, for instance, as a Colts fan, there's 32 total NFL teams. One of the 32 has to win the Super Bowl. So we could say, I only want the Colts to win. That is one desired outcome. I don't want anybody else to win the Super Bowl. How many total teams could win the Super Bowl? 32. So we'd say that's a 1 to 32 chance. How many of you sports people, though, you have multiple teams you cheer for? You're like, I got a few different teams I cheer for. Now, you can't cheer for Bama and Auburn. Are we agreed on that?
Yes,
you cannot cheer for them both, okay?
Agreed.
But let's just say, let's take the NFL, for instance. When I was growing up, the St. Louis Rams, back in the day, were in St. Louis. I hate them now that they're in LA. But when they were in St. Louis, I'm a Cardinal fan. St. Louis, I got a little bit of a connection to. So, you know what? If the Colts just stink on ice, if the Rams win the Super Bowl, that's kind of cool. That's kind of cool, too. Okay, it's not nearly his favorite, but, whatever. At least I'm kind of happy. Or also growing up in Florida, the New Orleans Saints, we refer to them as the Aints back then, but the New Orleans Saints were kind of the local-ish team, if you can believe it, even though they're, like 4 hours away from Pensacola. But they were kind of the local team for Pensacola, so the newspaper kept track of them, and, it was better if there was good news than bad news. So like, okay, well, if the Saints won the Super Bowl, that would kind of be okay too, except that the Colts played the Saints in the Super Bowl, and unfortunately we lost, and that was mad because we had a big lead at halftime, and then we blew it. Anyway, Saints did an onside kick to start the second half. Like, who does that? And we were not ready for it, so it's our own fault, but anyway, then they drove down. So then we had like 3 out of 32 teams I would have been happy with. If there were 3 desired outcomes out of 32, okay, that's kind of cool too. That increases my probability of being happy if you have more than one team, okay? I'm a Notre Dame fan. And growing up, Notre Dame was awful. I grew up in Florida. I added a second team. Go Gators. Well, things have really reversed roles now because now the Gators are horrible, and they've also got the toughest schedule in all of college football next year, so there's no way they're going to be good. And so that even if they're good, they're not going to be good. And so the Gators were my second team. If the Gators won, I was happy. I would rather Notre Dame won, but I knew there was no way Notre Dame was going to win anything, so go Gators. And so those are my 2 teams, kind of cheer for, kind of like at IU, Indiana football. Indiana's never going to win in football, so, you got to have another team if you're an IU fan too. So anyway, it increases your odds if there are more things that make you happy. If we think of a board game, how many have ever played Monopoly? We know how Monopoly, okay. So we all know Boardwalk and Park Place. If you own them, you got this game, right? It's in the bag. It might take time, but in the end, unless you really screw something up bad, you're going to win. But if you don't got them both and somebody else does, you know what I'm talking about. You have to roll the dice. You're on the green property, that little strip, and you're like, please, anything but a 6 or an 8. I'll even pay the luxury tax, just not Boardwalk and Park Place with their hotels. Come on, anything but 6 or 8. Anything but 6 or 8. You know what I'm talking about, right? Well, how many different numbers can you roll on dice? Well, on a single die, there's 6, but total on the dice, right? If you look at it, there's 12 different numbers you could roll. Now, the probabilities are all skewy, but just like, come on, anything but a 6 or 8 would make you happy. Pretty good odds. But if you're the one who owns Park Place and Boardwalk is still available, and you need a 9. Well, you can't get a 9 because you'd be on the go to jail list. But anyway, you need an 8, for instance. I got to roll an 8. Come on, 8. I just need an 8 so I can buy Boardwalk, and I'm going to seal this deal. Right? That's one desired outcome. right, over whatever. That's the idea of probability. How many things do you want to happen? How many things are you good with over how many total things could happen? Look at this little Sydney piggy bank there. And right next to it says, consider Sydney's coin bank, which contains 5 quarters, 3 dimes, and 12 pennies. Okay, so we have 5 quarters, 3 dimes, 12 pennies. First thing you got to do is figure out how many total things are in there, besides, dust bunnies. So how many total things, how many total coins are, and she's not going to be fooled by one of those, oh, I think I have a quarter here. Dust? No, she's not going to be fooled by that. How many coins are in the bank?
20.
20 total coins, right? 20 possible things she could pull out. And it says, well, what's the probability she chooses a dime? So we say the probability she chooses a dime is something out of 20. Well, there's more than one dime in the bank, right? How many dimes does it say are in there?
3.
3 dimes. So does it make sense then that there's a 3 out of 20 chance? 3 of the 20 coins are dimes, there's a 3 out of 20 chance she gets dime. Now, we can express probabilities in other ways. We can express it as a decimal, 0.15. We can express it as a percent. There's a 15% chance she chooses a dime. For this class, we're going to do the ratios. Okay, we're going to save ourselves the trouble of making decimals and making percents. We're just going to go with ratios, but they're going to be reduced. Write that off to the side margin of your book. Reduced ratio. For instance, let's say we were curious about the probability she picks out a penny. Let's suppose a younger sibling says, Sydney, can I have something from your piggy bank? And Sydney wants to be a sweet older sister. Some of you know Sydney. Anyway, shout out to Sydney. But let's suppose she wants to be a sweet older sister. Say, fine, I will give you something from the piggy bank. And so she reaches in. What is she hoping she gets?
Penny.
The penny. Not we get the dust. She's hoping she gets a penny, isn't she? Because she doesn't want to actually give up something of real value. She's like, kid will be happy with a penny anyway. So what's the probability of a penny? Well, how many pennies did it say were in the bank?
12.
12 out of how many total coins?
20.
20. But I can't leave it at 12 out of 20, can I? Gotta divide both top and bottom by 4, and we're going to say there's a
3 out of 5.
3 to 5 chance. And we already know that's 0.6 as a decimal, so 60%. So it wouldn't be hard to make that decimal or percent, but still, we're lazy. We'll leave it as 3 to 5. There's a 3 out of 5 chance she gets a penny to give to the kid. All right? Does that make sense? Seem pretty easy? No questions on that? But again, we want that reduced ratio. Look at the example at the bottom and read about, our pastor has a gumball machine. Anyway, read about Pastor Seth's gumball machine, if you would, Bryson. The example problem.
That's the gumball machine contains 15 gumballs, 3 red, 5 greens, 3 yellow, and 4 blues. Next time Seth wants a gumball, what is the probability that the machine will give him a yellow gumball? Assume each gumball is actually equally likely to be given.
My job. All right, anyone ever have a little gumball machine when you were a kid? I had a little gumball machine, and my little sister discovered she could just unscrew the top instead of putting a coin in. She just unscrew the top and take the gumballs out. She had a friend over, and they break into my gumball machine, put gumballs in their mouths, and go to my mom, hey, can we have these? I guess you can now.
Business.
Thieves. Anyway, I'm not bitter, Michelle. I'm not bitter. That's my little sister. Anyway, not bitter at all. Still remember this to this day. Anyway, the first thing we got to do, class, is figure out
How many?
how many gumballs are there, right? He wants a yellow one, but how many are there? Well, we don't have to figure it out. They were nice. They told us, class. 15 gumballs. That goes on the bottom. And so when we look at the probability of a yellow, by the way, notice the notation here. Capital P and then in parentheses yellow. P means probability, and in parentheses you say of what you want. The probability of yellow is, well, how many yellow gumballs, class?
3.
3. So there's a 3 to 15 chance, right?
No.
Yeah, but we ain't gonna leave our answer that way, class.
Reduce
Reduce it down to say,
1.
there's a 1 to 5. Notice we say it as a ratio, right? It's a 1 to 5 chance that he gets a yellow gumball. Turn over, if you would, to page 257. Flip over to page 257, and let's look at some little fishies here, some goldfish, even though some of these goldfish aren't gold. Fishies. All right, moment of silence for Argo. Excuse me, Argon.
Finally.
All right. Anyway, all right, so Miss Morse, our sentiments, feelings, and thoughts are with you during this moment of loss. All right, sort of. Go and read about the goldfish here, if you would, Luciana.
Harry's pet store is selling 30 goldfish, 10 striped, 9 orange, and 11 white. What is the probability of randomly selecting blank goldfish?
All right, so first of all, if we want to describe the probability of a white goldfish, how do I write that with the probability notation? What will we write, Luciana?
11 over 30.
Well, that's our answer, is 11 out of 30, but how do I notate the probability of a white goldfish? Not quite this exactly, but like this, we would say capital P, and then in parentheses, white. Probability of white is, and you already gave us the answer. I was giving you my next question, 11 out of 30, because there were 11 white out of 30. So, Luciana, how would I notate the probability of a striped goldfish?
P white equals 30.
We're on to letter number 2, a striped goldfish.
P striped equals 10 over 30.
Good, P striped equals, and there it says there's 10 stripes, so 10 out of 30, which we'll reduce to say 5 to 15, which we could further reduce to get 1 to 3. There we go, we just knocked the zeros off. And then for our last one, the probability, we'd say P, the probability of orange, which actually looks gold, so finally a goldfish. The probability of a goldfish, 9 over 30, but we're going to reduce that too.
3 over 10.
3 to 10. How many follow along with me? You're right there, everything, all the answers, you're like, yeah, I got this. All right, so look at the next set, the numbers 4 through 6, and read that for us. Any baseball fans in here? Baseball fans. Ben, read the 4 through 6 problem.
Philip owns a collection of 120 baseball cards, 50 shortstops, 30 pitchers, 25 catchers, and 15 left fielders. What is the probability that Philip will randomly select a blank card?
All right, now we're going to use a little bit of abbreviation, because in baseball we use abbreviations. So I'm not going to write for the probability of a catcher. I'm not going to put P catcher, I'm just going to put PC, because that's the notation for a catcher. And how many total cards does he have, Ben?
For the pitcher?
No, how many total cards does he have? Total, in his whole collection.
120.
Good, it comes right now and tells us that's the number that goes on the bottom, remember? And then on the top, we're going to put the number of catchers he has.
25.
25. We can divide what out of the top and bottom, anyone?
5.
5. I wish you could divide more, but you can't quite. So divide a 5 out of the 25, you get?
5.
5. And then divide out of 5 out of the 120. Anyone?
24.
24. Good, so a 5 to 24 chance that if you were to pick a card at random, it would be a catcher. All right, so Ben, let me come back to you for number 5. How would I notate the probability of a shortstop?
50 over 1.
No, how would I notate it? Notate refers to how I write it.
P parentheses.
Do you know what the abbreviation for a shortstop?
S.
Close.
SS.
SS for shortstop. Or not so tall stop if we want to not discriminate against certain people. All right, so anyway, we don't want to use the term short, it could be offensive, so we say not so tall stop. All right, anyway, we don't want to say first base man because, like, what if it's a female? So first base person, a first base individual. Anyway, all right, so not so tall stop, the SS for shortstop. And what's my initial ratio going to be here, Ben, for the not so tall stop?
50 over 120.
There we go. This is an easy reduction. All I got to do is what, Ben?
Divide
5.
5.
How about we knock off zeros, Ben? What do we get?
5 over 12.
So 5 to 12 would be our ratio of shortstops, our probability rather, that if I pull a card at random, set up straight, it is a shortstop. And then for the last one, for the pitcher, Ben, how do I notate it first?
P.
And then in parentheses
Pitcher.
is, you could write it out, I mean, that's just another P. Probability of pitcher is,
30 over 120.
let's reduce it down, Ben,
3 over 12.
and reduce it one more time.
1/4.
Wonderful, good. Which that one would be easy, right? If we were like 25% chance he gives a pitcher if he pulls a card at random. Good, questions on those? Look at number 7 through 10 and read that little set for us. Let's see, picture cards, animals, animal lovers out there. Elaine's like, I'm an animal lover. Okay, Elaine here.
10 picture cards are in a hat. 4 dogs, 3 cats, 2 rabbits, and 1 bird. What is the probability of randomly selecting a card with a blank?
All right, so for number 7, what's our notation, Elaine?
It is P, and then parentheses, cat, and then equals whatever.
All right, so now let's do the whatever.
The bottom would be 10 and the top would be 30.
There we go. And how many thinking 3 to 10? 30%. Chance of drawing a cat card out of the hat. For the next one, number 8, what would we put? Elaine's another, or she's Elaine. Jalen is another animal lover. Jalen, number 8, what should we notate?
P, bird, just have this
1 to 10. There we go. Let's see, I had another animal lover. Kirsten, number 9.
P, parentheses, or, yeah,
Mhm.
dog,
Good.
equals 4 times. Wait, okay, 1/5. Right, no, it's not.
Class help? Oh, she got it. 2 to 5. 2 to 5. There we go. Remember, we say it as a ratio with the word 2 there. And then number 10, one more animal lover. Joel?
P, parentheses, rabbit, equals 1/5.
Good. Initially 2 to 10, but we do reduce it to 1 to 5. By the way, if you can see the reducing before you start and you want to start with that, that is fine. Questions on that? Yes, sir. Go ahead. All right. We start to see the way we notate, things like that. All right, let's go to this next one. It's kind of unusual because I have seen one of these. A dodecahedron is a 12-sided die. So we'd have numbers 1 through 12. It's not a cube. It's a really weird shape with 12 different faces on it. That's what we have here. Is 12 sides on a game piece, and we roll. What's the probability of rolling number 11? It says an even number. Well, first of all, how would I notate the probability of an even number here? Griffin? Always start with
P parentheses even.
There we go, just P even. Now think about it. How many total sides on this thing?
12.
12, but how many of them must be even numbers?
6.
6, right? 2, 4, 6, 8, 10, 12. So what's the probability if I roll the dodecahedron that I get an even number?
1 to 2.
1 to 2. 50% chance I get an even number. At your seats, do number 12. At your seats, do number 12. And Joel, starting with the notation.
P, parentheses, odd, equals 6, 12, equals 2, 1/2.
Well, 1 to 2. 1 to 2. How many realized odd is going to be 1 to 2 also, right? All right, this next one's interesting. Think about it for a moment. The probability of rolling a 2-digit number at your seats. And I'll say here the probability of 2-digit. Probability of a 2-digit number. Bryson? How many 2-digit numbers are on the dodecahedron? 3 of them, right? 3 out of 12. So we're going to say
It's
1 to 4. There we go. How many had 1 to 4? 10, 11, 12 are your 3 2-digit numbers. Okay, so then the probability of a 1-digit number. How many 1-digit numbers must there be on this thing then?
9.
9. So we would say the probability then of a 1-digit number is?
9 over 12.
Which becomes? Anyone?
3/4.
3. There we go. You got it. 3/4. 3 to 4. All right. Look at the next one. Pencil case holds 18 pencils, 2 blue, 5 striped, 9 red, 2 pink. Let's probably be selecting different types of pencils. Do 15 to 18 very quickly at your seats. Do the 15 to 18 at your seat. We'll go over those answers momentarily. 15 to 18 about the pencils in the pencil case. Bless you. All right, Corey, what's the probability of red?
P parentheses red equals 118, which reduces to 1.
1 to 2. There we go. How about the probability of blue, Ben?
1 over 9.
1 to 9. Probability of striped, Elaine?
5 to 18.
5 to 18. And probability of pink, Joel?
1 9.
1 to 9 is how we'll say it. 1 to 9. Good. Go to the next one. Numbers 19 to 22. We got some math flashcards. Why? We don't know. But we have math flashcards. How many remember doing the drills when you were in elementary school? All right. How many would like to go back to those days? The probability of going back to those days is 0. Okay.
Unless you get put back.
Like that.
You can abbreviate if you like the first 3 letters,
Yeah, that's
sub, add, molt, div.
That's what I
By all means, yeah, those are really long words, so let's abbreviate. I mean, it's not wrong if you don't, just be lazy.
Long.
Or here we go. The ultimate.
Logic.
Boom! That's why they pay me the big bucks. Luciana's back there like, yeah, I already thought of that. She's a genius. The nice thing is none of these reduce.
Oh, they don't? Oh, I was just here learning.
So, saves us some time.
Yeah.
So what's the probability of a subtraction card, Griffin?
12 to 35.
12 to 35. How about the probability of an addition card, Jalen?
18, 30,
To 35.
18 to 35.
There we go, 18 to 35. How about the probability of a multiplication card, Luciana?
2 over 35.
2 to 35. And then the probability of a division card, Ben?
3 to 35.
3 to 35. To the page. All right, do the 23 to 26. Now this time they don't tell you how many marbles, do they? So this time you're going to have to figure out the total before you can go forward. So do 23 to 26. All right, for sake of time, just the answers. Probability of green, Joel.
2 to 9.
2 to 9. Probability of red, Elaine.
5 to 18.
5 to 18. Probability of purple, Kirsten.
3 to 18.
Well, let's reduce it.
1 to 9. No, I was.
Help.
1 to 6.
1 to 6. And probability of blue, Corey. 1 to 3. All right, homework for this evening is to do page 259 to 260. Page 259 to 260 in the homework section. Page 259 to 260. You're going to do 1 through 12 and 21 to 32. 1 through 12, then we're going to skip a section, 21 to 32. Pages 259 to 260. Do 1 to 12 and 21 to 32. Take a look at all of that as we continue talking about probability in our next lesson. What's the probability that Michael will be here tomorrow? We don't know. But anyway, have a wonderful rest of your day. You are
25.
dismissed.